Hello everyone and welcome to today's episode of Astronomy Answered Simply. I'm your host John Dodesky, where I talk about and answer interesting questions from Quora, which is a kind of a question and answer forum, about astronomy, physics, planetary sciences, pretty much anything star related, rocketry, all sorts of fun stuff. But I love science, I love astronomy, and I want people to learn. So, without further ado, today's question is, how come we can see a source of light extremely far away when the source only illuminates the area much closer to it? Okay, so this is kind of a fundamental misunderstanding of light. A star does not just illuminate the area closer to it. What happens is light spreads out like a wave. And as it gets farther and farther and farther, it gets dimmer and dimmer. I'm going to demonstrate this by turning my light off in here. And, well, that didn't flippin' help. I'm going to show you my flashlight. Notice how much brighter it appears as I get closer, except for the fact that the camera is auto-dimming. So now, as it gets farther and farther away... Really? Okay, so the optics in the camera keep adjusting the aperture to compensate. But as a light source gets farther away, it appears dimmer because the light is spreading out in waves. If you drop drop a pebble into a bucket of water, you'll see the waves spread out. They start off big at first, but then they slowly shallow out over time. So this is the light is still propagating infinitely and forever. Light will travel until it encounters another object and is absorbed. Photons will travel forever. So that is how we're able to see extremely distant objects. That light has traveled thousands, millions, or even billions or tens of billions of years because it's never encountered and been absorbed by another object. Photons from our sun, this bright light that I just shined on my face, travel 8 minutes to get to us. But so light from distant galaxies has been traveling for billions of years and is very faint, which is why we need larger and larger telescopes to look deeper back in time in order to gather enough light to actually make an image. There's two ways to gather enough light. You can have a huge telescope, and I'm talking football field-sized telescope like the one under construction in Hawaii on Mauna Kea. Or you take a smaller telescope and point it at the same point in space for a really long time. And if you want to see what that looks like, take a look at the Hubble Deep Field or the Hubble Ultra Deep Field. I'll actually put links to those in the Quora answer, because over time, it'll gather more and more photons from the same sources and make a clearer image. So the Hubble Deep Field, they pointed the Hubble Space Telescope at what was previously from ground-based telescopes thought to be, an empty part of the sky. In that part of the sky, which would be smaller than my pinky nail, smaller than that, if I held my arm out at arm's length, the area of the sky that would cover my pinky nail is about what Hubble was staring at. And in that, they discovered 10,000 galaxies, ranging back to I think 1 billion years after the universe was formed. It's absolutely gorgeous and breathtaking. And I think there's one astronomer out there, or one computer scientist, who took the information and made a 3D model of the Hubble Ultra Deep Field. And it truly humbles one and is just an amazing way to fathom the absolute awe, size, and grandeur of the universe. But to get back to the question itself, light is a wave, and it propagates in waves, much like in a lake or an ocean. Or if you fill up your bathtub with water, let it go calm. Drop a pebble in, right in the middle. Small rock, plastic, anything that makes waves. And you'll see the waves slowly spread out. That's the same way light expands out from a star, only it's not moving in 2 dimensions, it's moving in 3 dimensions. So I hope that helps. If you're still having trouble visualizing it, I'll put a couple more links in the Quora answer and about light and how it propagates to help you understand. But this is really, it's a fundamental property of light is that it moves like a wave. Granted, the weird thing is light is also a particle. And only in the last, I think, year or two was there an experiment that was able to observe it as both a wave and a particle at the same time, which I still can't wrap my head around, even though it's like previous experiments only said it can be a particle or a wave, but it depends on how it's being observed. But there was this new method that I need to find the link for, but that was able to observe it as both a particle and a wave at the same time. And I was just like, mind blown, because it's freaky and it's just, sometimes physics, even though it's the laws of nature as we know it, is really weird and just seems to just absolutely boggles the mind. Wait till you study quantum mechanics. That stuff is crazy. Anyway, so distant objects. Take a flashlight. Go at home. Get a really big room. Take a flashlight and pull the flashlight farther and farther away from you. Or, go into a completely dark room. Shine a flashlight. Have someone, shine a flashlight close to your face. You'll notice it's brighter. And then pull it farther and farther and farther and farther and farther away. Eventually, if you do this, let's say, at night in a really dark field, it'll disappear. However, if you grab a binocular or something, you might see it again. It's the same principle. I'm just trying to think of ways that you can test this at home and duplicate it and understand this a little bit better. So, pebbles in your bathtub, flashlights at night or in a really large room, and telescopes are basically, telescopes are light buckets. They are buckets meant to capture light. That's what a telescope is. That's what astronomers study, is light in all forms. And not just visible light. We study the electromagnetic spectrum, like X-rays, gamma rays, ultraviolet rays, infrared rays. All spectrums of light is what gives us the data to make astronomical models and astronomical predictions. So, that's all I got for the day. I don't want to keep rambling on and on and on, but I'm hoping I have helped you with a little bit more of an explanation and a little bit more understanding. It's not that stars illuminate just the area next to them, but it's that they brightly illuminate the areas next to them, and the farther away you get, the more diffuse the light is, and so hence it appears dimmer. But there's literally starlight all around us. It's just really, really, really faint and dim. The farther away you get from the stars, the dimmer the light is. So that's all for today's episode. Thank you. Like, subscribe, watch, send me questions, send me requests. Have a great day. Keep learning. Keep looking up.